Dr. Gonzalez-Franco is a computer scientist and neuroscientist at Google. Her PhD work at the Universitat de Barcelona, joint with MIT, included a project in which subjects in virtual reality had their virtual hands stabbed with a knife. A thrilling continuation to the rubber hand illusion, first published by our very own Professor John Cohen and former Professor Matt Botvinnik. Brain activity confirmed that subjects had a strong illusion that the hand was their own. But not only that, the experiment demonstrated that certain brain signal signatures could be used to objectively measure our embodiment in virtual reality. Matrix? Anybody? During her postdoc work at University College London, Dr. Gonzalez-Franco also replicated in virtual reality the famous Stanley Milgram experiments, in which subjects choose whether to obey an authority figure, asking them to harm others. But there were subtler findings there suggesting that while subjects did obey, they also tried to covertly warn their virtual victims. Since then, Dr. Gonzalez-Franco has pursued numerous other projects, including developing the avatars used in Microsoft Teams, awarded a Times Magazine Invention of the Year last year in 2022. She is an expert advisor to governments, including the United Nations, the European Commission, the Natural Sciences and Engineering Research Council of Canada, and the National Science Foundation here in the United States. Please join me in welcoming Dr. Gonzalez-Franco.
Thank you. Thank you. Thank you, everyone. I don't stab hands of people anymore. This is the title I choose for today, Defining a New Immersive Reality. It's kind of an oxymoron because we already live in an immersive reality. But I feel like the new tools that we're getting here kind of redefine a bit of it. And also, I think the examples that were just mentioned sort of show how these technologies can be a petri dish for a lot of research. A bit about me, which was already introduced. I have my very scientific background. I'm also very interested on how do we drive innovation in tech companies. And so I work mostly in these tech companies trying to, I feel many times they're like the very big applied research lab for humanity. And I still publish a lot of the work that I do. What is happening right now is that we're in this paradigm shift in which we have these technologies we've been using quite long, in which the content is inside the screen. We're just moving into this very different form of interaction where the users are inside the content. And I feel like this is the third time an interaction paradigm really changes how we interact with devices, right? We used to have computers, they became mobile in a way with laptops. Then we had the phone, and now we're moving into this new space. And it isn't so obvious how we transfer things, even how you interact with things. However, if we look at how we interact with things already, we have so many affordances that we expect to be fulfilled. So it's very hard to design things that work in this space. So I sometimes feel that we have evolved so much through technology that it's more about curating a museum that what we need to do, right? You could add so many sensors to any of our devices, but they make sense. And I feel like that's where neuroscience, interaction, perception, all of this knowledge about humans and how we interact becomes very, very important and the core of defining how these technologies should be shaping. Every year we see many of these kind of like the top 10 something. They look very similar to me. They present some technologies that will be revolutionary for humanity. And we all agree on them, I think, most of us. And then some that are not so obvious and people are not agreeing that they change everything. So they give you these voting things. Oh, you can vote. And some of them are clearly scams, right? So you're like, oh, wow, this is very confusing. And I think things like the Metaverse, which I will go a bit now into the naming per se. But, you know, I feel like this idea that how we interact with content is something that often is locked down into, right? Like people don't believe it's such a big thing, right? Like it's not even a technology, right? It's just an aggregation of technologies. But then it gives the biggest surprise because it really changes how we interact with the content. And that layer that touches the human is precisely what changes society. So I was mentioning Metaverse. I think the hype is kind of going a bit down on Metaverse, but I want to show this a bit as a focus shift. So there will be this, and it will happen often, that we're moving into, we're building these new devices with the new capabilities, and then we focus on what we can do with these devices, right? That Metaverse is one of the things we can do. And I think that's clear for now. However, the predominance of the word Metaverse might actually change in the same way that, this is 1993 Times Magazine. Information highway is what we now know as the internet, right? You read these articles here, and they are not wrong. Many things are true. But the name, they didn't just get it. So I do think that we're on a vocabulary development. It's very common in human. Vocabulary is something defined through discussion. Even some things have asked the philosophers from Greece, and later the Germans will still write philosophers trying to figure out exactly what the meaning were of the same concept. So I do feel like that occurs in many other aspects of human existentialism, that we define vocabulary as we go. And that includes metaverse, extended reality, virtual reality, augmented reality. I'll go across course into two very extreme ways of this. One is this idea that you enter a completely new space, you put on this, and you're in a new place, right? So completely occluding your reality, you enter a new space. We'll look how this feels in later. And the other one is that you're in your real life. I have these sort of augmentations with glasses of some sort, right? You're provided information in real time. You're given, transcription of some sort of information there. It's a hard problem because it requires a lot of a scene understanding of what your surrounding is. But I think we're getting there too. And the two options basically look like this. Eventually, maybe they merge, who knows? One of them is really transparent and you project on top. The other is you merge it through an occluded display. What is really happening sometimes with these technologies is that the reason why they enter our radar, it's not how ready they are, but how much money is put on them. and when the acquisition happened of Oculus, perhaps that was still on a very early stage. So it does feel like, it's never happening, right? But it's adding on, right? Like if you were to say, where is this on these curves, typical hype curves, then you see that they are advancing, right? Whether it's up or down on the hike, the technology keeps advancing on the x-axis. The other thing that happens is that there are many technologies involved in this. As I say, it's like a combination of many things. And then we confuse this idea, it happens so fast. And Ivan Sutherland is like a 50-year-old type of thing. The mouse took 30 years. We have all sort of this kind of time span. But the trend is clear. We come from a world in which digital and real were separated. Then we started blending them, and this is coming more and more. What this means in real life, because we only have 24 hours a day, we will blend with that restriction of time. And then you also have like basic needs that you need to cover in these times. So the truth is that if you have time to dedicate into going into a completely virtual space, could be considered entertainment. That can be a good target for a metaverse in which you're completely there. Some of us, if you have children, you don't have that kind of time. So Metaverse is kind of off the table for many people. In other spaces where you're targeting work, whether it's augmenting a first-line worker or information worker, then you have the 8 hours of work, right? Sometimes more. But yeah, in general, you would look at how people are going to use these technologies, and you also see different industry players in different corners of this equation, right? The truth is people fantasize a lot about this one on the real world. I think it's the hardest one to make. So starting there, sometimes I wonder if people believe in evolution or in aliens. And the truth is that technology is purely evolution. The other interesting thing about this adoption that I think on the ethics, it hits a bit on the ethics, and Casper Hornbeck was talking about it recently to me, and I thought, oh, this is very interesting. It sort of feels like, especially all this social media has based all the applications of it into this what feels good right now, hedonia. And I think if we're really going to build an experience where we augment reality, we should be pragmatic for sure, but also focus a bit more on what this means for the whole human on the longer term, right? And this purpose with life. And that brings us into these technologies are experience machines, right? You create experience with them. And what if you had a machine that could give you any experience you desired, right? And it would be certainly better than reality, because reality doesn't provide any experience you desire. And you could be younger, happier, all these things that you aim for in life, perhaps, which TV sort of already does, right? You turn on TV and people are richer, happier, cuter, everything more than you. Your life is much worse than that, so people get hooked into that. So what if you could do that, right? Like, are you worried of missing another desirable experience, real ones? And I think this is something that I wanted to bring here. Is kind of an old thing. I think I'm not sure if it's a neural experience or just a device you put on, right? Anyway, so for now, I've talked a lot about the devices. And for the longest time, I thought AI and VR were like two parallel techs that, both were cool. And we kept seeing things like this. And I think we all thought AI would be very good at mathematical problems. And in fact, it is, right? Like, it's doing amazing things for us. But then it also did something that I thought was science fiction, right? Like, you would see these TV shows of CSI, whatever, and they'll be like, augment the plate. And you'll be like, man, this breaks the laws of physics. But apparently you can do these things. So this might have passed somehow under the radar for many, even in the computer science or in the science industry. There was already this idea that you could resolve objects below diffraction, and they won a Nobel Prize. But I think the breakpoint for everyone in computer science was in 2019 when they reconstructed an image of something you cannot see with accuracy, right? The black hole for me was this idea that, okay, this seems impossible. You use all the images in the world to show another image of something you've never seen, and it's accurate to laboratory equipment accurate, right? So that use sort of diffusion models, which are these models that start completely with noise and clean the noise up to a point that you can do in painting all sorts of things, right? And then you can also do a multi-modal model where you add language into the description, and you also see how it improves as you add parameters to it, to a point that if you didn't know this is impossible, you'll think like, yeah, there is a kangaroo with a sign in front of the opera. of Sydney. And this is also changing how we do XR. So this is the first connection. So here we have sorry for that, a completely integrated experience inside VR, right? And I'm not gonna enter, but this type of tool allows you to create any right? So that's one of the examples of how it's already this AI is merging with VR and other immersive technologies. There is this class online that I really recommend. It's 1 hour, and it has examples, and it really explains how this noise to definition model works. But in general, it's not just about creating the content, but I feel like how we interact with AI is gonna be through the devices. And you can already see that in these AR augmented experiences where you can have a person who has never learned to read being able to function normally in life, right? But on top of this, if we can use this as a wearable, it really, really revolutionizes. So for me, all of this redefines what's real and what's not, right? When we start interacting with these devices and this type of level of understanding that we can create new content and also understand the current content. And I think VR is really the lab tool for cognitive scientists and neuroscientists, right? Every science has had a lab tool, right? And I think for the longest time, in neuroscience, I mean, if you're doing basic neuroscience with the actual cells, and you have a lot of lab tools, but if you're trying to explore the mind, yes, you have MRIs, all of this to measure things, but not to create this sort of like experimental conditions, which I think you can do now. And so, you'll move from, I had to show the rubber hand coming to Princeton. You'll move from mannequins into maybe having avatars. There was a time when I started using avatars where people thought VR was Second Life. It was very hard to publish anything in serious places. And I often thought, oh, I wish we were using mannequins. And it would be easier for us. But I think now we're over that. I'm seeing a lot of premium work being using VR for the experiences. And this is something you can perfectly replicate inside VR, right? This is because VR creates this very good experience on interface between the brain and reality. And that's because humans are such a multisensory animal, and we do Bayesian inference for all of the modalities of our sensing that we perceive. That's the rubber hand illusion, touch, and vision. And it's even worse because the multisensory integration has a super additive behavior, right? In which if you have more than one modality telling you that something is real, it really kicks in, right? We have all these top-down and bottom-up inferences that really define our reality through the experience of our sensing or of our mental imagination. And in the end, what happens is that through the evolution of so many centuries, we have developed a system in which we have cognition through sensing, we process all of this, and then also we drive behavior. I won't go very deep, but this means that we can use this tech to explore how people touch things, right? The whole idea of haptics, how people perceive their bodies with things like the embodiment illusion. I'm just gonna very quickly try to play this.
Virtual reality enables users to sense a virtual body beyond their physical presence.
having an avatar in a first-person perspective. I look at embodiment through many ways, also stabbing hands. The importance of the body, it's so critical that the US still use feet as a metric system, so I don't need to go there. But there are many reasons why this works. And then in virtual reality, you can do very interesting things in which you can create these illusions, right? Like your very long nose, etc. There are effects of this, like people try to follow their avatar. And with that, we can play all sorts of motor control experiments, right?
Requires fast online corrections that compensate for sudden object shifts or postural changes. In the current study, we investigate how
I will
sensory motor
play a little bit of this
associated
video.
with space
So
perception,
here,
brain
we're
lateralization,
redirecting a
biomechanical
person by
constraints
showing
affect the
an
efficiency of
avatar
online
hand
corrections.
that is moving
Participants perform
away from
routine
them,
actions
and they
in
try
virtual
to
reality,
follow, right?
where the virtual hand is
So
progressively displaced from
this
the
way,
real
you can
hand
study
to
all
trigger
these
online corrections.
motor
We can
control
control the total
and
amount of redirection
all the
and the version of
paradigms that
space in
have
which
to
the
do
action
with
unfolded.
implicit
We
models
had trials where the
of
virtual hand and
our
real hand
body,
had no redirection.
and explore the whole space in a very easy way, right? Like try to do this in reality is much harder. So again, this idea that you can use this tool for analysis. The interesting thing is that this breaks. If you really move the hand of the avatar in the wrong direction, you can disrupt all this sense of agency. And it correlates very nicely with the questionnaires. So many of these things are also perceived internally, but also can be measured externally. In fact, one of my most used papers is a questionnaire. And these are many of the challenges that I'm showing here are things that I've been working on, right? And trying to generalize so everybody has these authoring tools, etc., these touch systems. And I will just finish with this one that it also can be used for behavioral analysis, right? And it's not just behavioral analysis. It means that it will induce behaviors in final users. So we need to account for all of these when we go there. I'll just play this video for the end, if I can. And with that, I finish my talk. This is a cave. I'm not sure if people here are familiar with the cave. Before HMDs could have a wide field of view, this made a lot of sense because you could have a really immersive experience that you feel like you enter a new space. And this experiment took me like 6 months to create it. So for the longest time, I dedicated a lot of effort to create tools so people could do this in 15 minutes. And I released some of these tools in my time at Microsoft. And they are available, the Rocketbox avatars, all of these. And I do feel that it might take even less in the future, right? So through all these AI advances that we're seeing, that things are generated from this text, right? I want the avatar to go from here to there. It will go in the future. Anyway, so I wanted to finish. I work with many people. And thank you, everyone. Thank you.
So we have some time for questions. Any questions?
They feel nausea or something while wearing these weird glasses and so on. So how do the people who are creating this technology trying to answer that challenge?
Yeah, I think the question is about nausea. Sorry for the people who are here. I think, first of all, this has changed a lot. I don't know when did you try technology last. I also was the first demo they did with the first decade that was for everyone to try was a roller coaster. And I was like, man, can you make it worse? I think it has improved a lot. It has a lot to do with the sensing system for the head tracking. and that has much less latencies, far more stable. Still, there is a lot of work, and some of the work I've done also tries to see how can you do locomotion and best ways to do locomotion without nausea. And if you don't have to locomote, your nausea is generally very, very low, right? It's locomotion or things that you feel like you're moving and your vexion is not, vestibular system isn't working. So I feel like these things are still, it will always be a human limitation, right? Because humans are basically, if your senses don't align on vision and motion, you have been trained through evolution to feel nauseous because it probably means you've been poisoned, right? It's very hard to trick that. But I do think that also over exposure, you might improve it. And there are ways, for example, if while you're moving, you reduce the field of view, and you have this tunnel vision sort of thing. You reduce it, you reduce the frame rate of, you were jumping from here, here, here. So you don't have this super motion. It helps. And what most people are using is this teleport, which I think it's very bad for spatial understanding. It's don't know how you get to places. You have no idea of mental mapping, which has been also something that I explored in the past quite a bit. But there are ways to trick it, and people are looking at it.
It seemed like even last year when the hype cycle around Metaverse was kind of reaching its peak, these counter-emerging narratives around motion sickness was coming out. There was a significant amount of population experiencing that. How do you anticipate the unintended implications when exploring this technology when it leads to things like the unintentional exclusion of folks along the way?
Yeah, this is something that worries me a lot, especially for the accessibility reasons, because we're talking about a technology that for the first time is more immersive than all the previous, but less accessible because it's a wearable. So if you cannot wear it, it requires in many times embodied interaction. So if you cannot move it, and also it, these two are quite complicated to solve. So my take on this is that we need to have bring as much of the interaction models of things we have already into it, make it interface with existing tools, especially if this is to be for productivity, right? Because there are countries with laws of equal employment opportunity, and you cannot provide opportunities for everyone if you only use a tool that doesn't work for everyone. So I do think this is top of mind for many people.
I'll have to wrap up.
Yeah,
But
good.
But there will be more time for questions at the panel. So
Okay, thank you.
Please.